Hello everyone, I am Harshita from Sri Venkateswara College of Engineering. In this video, let us discuss about structures and unions, stack, push and pop operation, queue, insertion and deletion, linked list, insertion and deletion. Next, let us see the introduction to unions and structures. Structures and unions are user-defined data types in C and C++ programming language. They allow you to combine different data types in a single variable. Structures and unions provide a way to organize and store related data efficiently. Let's see the syntax of structure. The syntax of to define a structure is structure name of open flower bracket data type member 1 semicolon data type member 2 so on data type member n and close the flower bracket and semicolon. Each member within the structure has its own data type. You can access the members using the dot operator followed by the member. Now let us see the example of structure. Struct employee, open flower bracket, int m id, char m name 50, float m salary, semicolon, close flower bracket, semicolon. Here we define a structure called employee with the three members, employee id, m name and m salary. The members can store an employee's id, name and the salary details. And next, let us see the syntax of union. The syntax to define a union is union name, open flower bracket, data type member 1, data type member 2, semicolon, so on, data type member n, and close flower bracket and semicolon. Unlike structures, all members of the union share the same memory location. Only one member can be accessed at a time. Example of union. Union data int value, float value, char string value of 50, semicolon, close flower bracket, semicolon. Here we define a union name data with three members, int value, float value and the string value. The memory allocated for the union will be equal to the size of the member. And next, let us see the introduction to stacks. A stack is a data structure that allows the last in first out LFIO principle. Elements are added and removed from the top of the stack. The push operation adds an element to the top of the stack. The pop operation removes the top element from the stack. Let us see the syntax of stock push operation. To push an element onto a stock, use the following syntax. Void push stock name yes, comma, data type value, open flower bracket, yes tends to array of s plus s tends to top is equal to value and a close flower bracket. Here stock name is the name of the stock and the value is the element to be pushed into the stock. Next, let us see the syntax of stock pop operation. To pop an element from a stock, use the following syntax. Data type of pop of date start name yes, open flower bracket, return s tends to array into s tends to top minus minus semicolon closed flower bracket. The top element is written and removed from the stock. And next, let us see the introduction to queues. A queue is a data structure that follows the first in, first out FIFO principle. Elements are added at the rear end and the queues and removed from the front end. The insertion operation adds an element to the rear end and the delete operation removes an element from the front end. Let us see the syntax of queue for the insertion. To insert an element into a queue, use the following syntax. Void insert queue name, queue data type, value. Open flower bracket, q tends to rear n plus plus, q tends to array, q tends to rear is equal to value, semicolon, close flower bracket. Here q name is the name of the queue and the value is the element to be inserted. Next, let us see the syntax of the queue, that is deletion in the queue. To delete an element from a queue, use the following syntax. Data type element, queue name, queue data type value is equal to q tends to array, q tends to friend, q tends to friend plus plus, return value, closes flower bracket. The friend element is returned and removed from the queue. Introduction to linked list. A linked list is a data structure that consists of a sequence of nodes. Each node contains data and a reference or the link to the next node. Linked list provides dynamic memory allocation and flexibility in storing elements. Now let us see the insertion in linked list. To insert a new node at the beginning of the linked list, update the next pointer of the new node. Example, void insert int value, open flower bracket, struct node, new node is equal to struct node, close it or flower bracket. And next, let us see the deletion in a linked list. To delete a node from the linked list, update the next pointer of the previous node. Example, void delete int value, open flower bracket, struct node, temp is equal to ed, semicolon, struct node and closed flower bracket. Finally, I conclude that structures and unions allows you to combine different data types into a single variable. Stock follows the last in first out principle while the queue follows the first in first out principle. Linked list provides flexibility in storing elements and dynamic memory allocation. And thank you for watching this video.